Today, we're diving into something really cool, teaching an AI one of the most human skills there is. And I'm not talking about writing a poem or painting a picture. I'm talking about invention. Can an AI actually build a complex machine from the ground up? You've probably heard this quote from Benjamin Franklin: "Man is a tool-making animal." For all of human history, our ability to imagine, design, and build tools has been what sets us apart. It's literally the engine of progress. So here's the big question for today. What happens when the tools themselves start making the tools? Can an AI, like a large language model, actually learn to think like an engineer and invent a working machine to solve a problem? Okay, so here's how we're going to break it all down. First, we need to understand the huge challenge these AIs are facing. Then we'll look at two totally different ways to solve it. One is like a team of AIs working together, and the other is all about learning by doing. And finally, we'll put them head-to-head to see which approach really works best. Right, so before we get into how an AI builds something, we've got to wrap our heads around the size of the problem. And trust me, this isn't some simple puzzle. It's a seriously massive design challenge. The official name for this is compositional machine design. But what does that actually mean? Well, think of it like this. You have a box of standard parts, and your job is to build a working machine, say a catapult, that can do a specific task, all inside a world that has real physics. Now, here's the real kicker. It's what's called an exponentially large design space. Just imagine you have a Lego set, but with an almost infinite number of different pieces. The number of ways you could stick them together is astronomical. But only a tiny, tiny fraction of those combinations will actually build a car that drives. The challenge is finding that one working design in a haystack the size of the universe. So to test all this out, researchers built a virtual sandbox called BesiegeField. It's basically a playground where these AI inventors can build their machines, run simulations to see if they work, and get instant feedback on how well they did. It's the ultimate test track. So how in the world do you solve a problem that big? Let's meet our first contender. This method treats machine design like a group project run by a whole team of specialized AIs. This approach is called Agentic workflows. The core idea is pretty brilliant. Instead of having one single AI try to figure everything out, you break the problem down. You create a team of AI agents, each with its own job, and they work together, kind of like a real-life engineering department. In this AI team, you've got three main players. First, you have the designer who comes up with the initial blueprint. Then, the refiner steps in. Its job is to be the critic, to look for flaws and suggest ways to make it better. And finally, the environment querier takes the design, tests it in that virtual world, and reports back on how it did. This whole cycle just repeats over and over, making the machine better with every single pass. Now, for this whole team thing to work, these AIs need some pretty serious skills. We're talking accurate spatial reasoning. They have to understand how 3D objects actually fit together. They need high-level knowledge of design and physics, and they have to be amazing at following instructions perfectly. This is so much more complicated than just generating a paragraph of text. Okay, on to our second contender. If the first method was an engineering team with a blueprint, this one is more like an apprentice in a workshop. It learns through pure trial and error. A lot of trial and error. This method is all about something called reinforcement learning. And the idea here is completely different. It's not about planning from the top down. It's about learning directly from the results of your actions, all guided by a simple reward. See, this AI has only one goal: get the highest score it possibly can. So for a catapult, that score is based on a simple question: how far did it throw the boulder? Every single attempt gives it feedback. A great throw means a high score. A terrible one gets a low score. And over thousands, even millions of tries, it starts to learn what actions lead to bigger rewards. And you can literally see it learning right here. The basic model starts out pretty clumsy, gets a really low score. Then, after getting a little bit of training on some already successful designs, it gets better. But the magic happens with full reinforcement learning. After tons of practice, it figures out a really clever, high-scoring design all on its own. And this really gets to the heart of the difference between these two approaches. The AI team tries to reason its way to a great design, but the reinforcement learning model, it just feels its way there. It internalizes all that experience until it develops a kind of intuition for what works. All right, so we've met the contenders, the methodical design team versus the experienced apprentice. Now it's time for the main event. Let's put them head to head and see who actually builds the better machine. So just to recap, we've got two completely different philosophies for how an AI can invent something. You have agentic workflows, which is top-down. Start with a plan and perfect it. And then you have reinforcement learning, which is bottom-up. Discover the plan through a whole lot of experimentation. And the results? Well, they pretty much speak for themselves. When trying to build that catapult, a single AI working alone gets a pretty dismal score of 2.3. But when you introduce that simple back-and-forth editing process, our designer and refiner team, the score doubles. But the real winner, a more complex hierarchical team, it almost quadruples the score, hitting nearly a 10. The takeaway here is undeniable. For these powerful models, collaboration and structured reasoning just build way better machines. But let's be real for a second. This is an incredibly difficult job. Even the best AI models still make a lot of mistakes. They'll put parts on backwards, attach them to the wrong spot, or just have a basic misunderstanding of physics. Building stuff, even in a virtual world, requires a level of precision that's really, really tough to get right. So which path is the future? Well, it turns out it's not that simple. There's a place for both. For the most powerful AIs we have today, that team-based agentic workflow is the clear winner because it plays to their strengths and reasoning. But for less capable models, reinforcement learning is the perfect teacher. It lets them build up that core knowledge from scratch, just through pure practice. And that leaves us with this one final fascinating question. As we look to the future, are the next great inventions going to be designed by collaborative AI teams that can reason just like human engineers? Or will they come from a single AI that has built up an incredible intuition from experiencing a million failures? The answer to that is probably going to shape our world. Thanks for tuning in.